Let me try and give the shortest possible introduction to the idea of linear algebra, sometimes also known as matrix algebra. So let me start with all that we're talking about here is a matrix, and a matrix is just a grid of numbers, right? So we've got, say, m rows and n columns. That might be, say, 2 by 2, right? Or you might think about, say, a photograph. A digital photo is a matrix. Really, it's 3 matrices, one containing values for the level of red light at any given pixel, another for the green light, another for the blue light. It's all matrices. Matrices are all around us, but as intimidating as it sounds, it turns out to be pretty convenient once you kind of get over that hump if you're doing some particular things. In particular, it is incredibly convenient to use when you're dealing with data on a computer. And not just, say, economic data, but also, say, camera data, visual data can be used to run a neural network. Economic data could be used to calculate a linear regression, but it's also used to, say, generate computer graphics. It's all over the place, and it sounds like a big deal because it is incredibly important for doing some really big things, right? If you want to be a physicist, you got to learn linear algebra. If you want to be delving into neural networks, you need to learn linear algebra. But really what it does is it gives us some rules for dealing with these sorts of grids of numbers that allow us to do math, right? It's basically a way to say a lot with not a lot on the page. So for example, this equation here is the equation that defines ordinary least squares. And what we can think about here is X is some sort of a matrix of data, right? So we got a bunch of observations in the rows, and then we got different variables in the columns. So however many variables we've got, we might have 100 variables to predict something like whether or not a customer is likely to buy your product, right? Or what GDP is predicted to be next year, or what the price of Apple might be under certain assumptions. So we take that block of data and we do some stuff with it, and then we do some stuff with another block of data, which is, in this case, a bunch of rows, but only one column, just whatever our variable of interest is. We put this together in this way, and we're able to get a slope coefficient out of this, if I'm remembering this right. So what do we get? We use this, we can say y hat equals beta x, and see if I remember this. We do x over that, and basically the whole thing cancels out. It's the sort of thing that you can kind of get a sense for. And you get a sense for it by taking many, many economics and statistics and machine learning classes, and finally it starts to feel natural. And once you get past that hump, it really becomes like a way to multiply your ability to think about these sorts of systems. Now, the problem that we run into, especially in a class like this, is that we often spend a lot of time on these mechanical aspects of matrix algebra, things that are easy to put on a test, things like being able to invert a matrix, but that is not a very useful skill because, well, we want the computer to do it. Knowing what's going on in the background is helpful for rooting your understanding in theory, but much more valuable than that is figuring out how to get the computer to do this hard work for you, and then you can actually use these systems to build these powerful sorts of tools. And these will work in a really wide range of settings. Anywhere where you can do algebra, basically linear algebra is a way to, instead of doing it one variable at a time, you just kind of stretch it out into an extra dimension, right? You just add all those columns, and it can all go together. So we're going to really, really briefly look at linear algebra. In this class, we're going to see just a couple simple of these mechanical things, but I want you to bear in mind that really the power of linear algebra is in allowing us to really condense a lot of things down into something that's relatively straightforward, something that uses not very much ink to say a lot. Because when we can do that, and when we can get data in a nice grid, or we can generate data in a nice grid if we're, say, trying to make computer graphics for your favorite game, when we can do that, we can harness the power of our computer to do a lot of calculations in a relatively efficient way. And that can really matter when we start dealing with these really big, complicated ones. Now, I haven't actually told you anything about linear algebra, but hopefully I have impressed upon you that this is a really ultimately very cool tool. It's a little bit of a hassle to get your head around it the first time, but it is really worth it if you want to do these big things or if you want to dig deep into other areas. So in the next few videos, like I said, we'll see some light duty stuff, but I really implore you, check out that 3 blue 1 brown playlist below this one, because he did a really nice job of sort of showing how you can use linear algebra to stretch spaces and to sort of basically do a lot of math all at once. And then also, check out some videos on, say, how neural networks work over winter break or summer break, and you might get some appreciation for just how useful linear algebra can be.